In the previous lesson, we learned about finding trig functions of any angle. We were able to use the reference angle and a diagram to help us figure out the angle measure that we needed to use, whether or not the trig function was going to be positive or negative, and how to calculate from there. Today we're going to talk about finding remaining trig functions under certain conditions. And I like to call this the bow tie diagram because when you draw it all out, it kind of looks like a bow tie. So here's what you're going to want to do. Again, this is something that the visual really helps when you are solving these types of problems. The first thing you want to do is figure out which quadrant the angle that you're dealing with is in. Then draw the triangle in that quadrant with the reference angle, and then label the sides. Now, the key thing that you have to remember here is that the hypotenuse is always positive. Okay, so that's going to be super important. So let me explain to you what I mean by the bow tie diagram. If you have an angle in the first quadrant, when you draw in the triangle, when you draw in your right triangle, your theta is here. And this side is positive, this side is positive because they're both on the positive side of their respective axes. Hypotenuse is always positive because it's just a distance. Okay, so that would be if you were in the first quadrant. If you are in the second quadrant, right here is your theta. You are on the negative side of the x-axis. You are on the positive side of the y-axis, but the hypotenuse is always going to be positive. In the third quadrant, right, so there's your right triangle. Here is your theta. Again, you're on the negative side of the x, you're on the negative side of the y. Your hypotenuse is always positive. And if you're in the fourth quadrant, here's your theta. You're on the positive side of the x, but you're on the negative side of the y, and your hypotenuse is always negative. So that is the bow tie diagram, right? So it's just showing kind of all of the angles depending on which quadrant you're dealing with. Now, you're not going to draw all of them at the same time. It's just going to depend on what quadrant you're dealing with based on the problem that you're working on. But I like to call this the bow tie diagram because it shows when you put them all together, it kind of looks like a bow tie. So this is really going to help you when you get to the problem. So let's go through a couple of examples so you can see what it is I'm talking about. In problem number 1, it says sine of theta is 5/11 and the secant is greater than 0. Find the remaining 5 trig functions. So this information right here is going to tell us which quadrant we are in. Remember, if we do our little kind of visual here as to figuring out which quadrant we're in, sine is positive in 1 and 2. Secant follows cosine, so wherever cosine is positive, secant is positive. Secant is positive in 1 and 4, so we're definitely going to be in quadrant 1. So I'm going to draw my picture in quadrant 1. Oops, pretend that's a right triangle there. Okay, so here is my theta. My angle, or the sine of theta is 5/11, so opposite over hypotenuse, that's 5/11. In order to find my other 5 trig functions, so to find cosine, tangent, cosecant, secant, and cotangent, right, I first need to find that remaining side. And I can do that simply by using Pythagorean theorem. Okay, so if I just called that a, I have a squared plus b squared, or 5 squared, is 25, is equal to 11 squared, which is 121. Okay, so I have a squared is equal to 96. Right, so a is going to be the square root of 96. Okay, we certainly can simplify that. The factors of 96 would be 16 and 6. Right, so that would be, I'll write it over here, square root of 16 times 6. So that would give me 4 root 6 for side A. Okay, so I can write that in. That would be 4 root 6. So we are on the positive side of the x-axis, so everything here is going to be positive. So I can then figure out what my remaining 5 trig functions are. I have cosine. So cosine is going to be 4 root 6 over 11. Remember, we should always write our angles in simplest radical form, our solutions here. Tangent is going to be opposite over adjacent, so that's going to be 5 over 4 root 6, right? So when we simplify that, we get 5 root 6 over 24. When we simplify, right, multiply the top and the bottom by root 6. All right, I'm just going to squeeze it in up here because I want to make sure I have room for my other problems there. Let's do cosecant, tangent, then cosine, tangent. I need cosecant. Cosecant of theta is just going to flip sine. So if sine was 5 over 11, cosecant will be 11/5. Secant of theta is going to flip cosine, so that would be 11 over 4 root 6. So when I simplify that, I get 11 root 6 over 24. And then cotangent of theta is going to flip tangent, so it would be 4 root 6 over 5. Okay, so very straightforward to do these problems. It's just a little bit, I don't even want to say it's that time consuming. It's just that you have to go through the steps. Okay, so let's go to problem number 2 here. It says if the tangent is 8/3 and cosecant is negative. Okay, so tangent is positive and cosecant is negative. Let's go back up to our graphic here. Tangent is positive in 1 and 3. Cosecant is negative in 3 and 4. So that tells us we're going to be in quadrant 3. So I'm going to draw my bow tie part that's in quadrant 3. So here's theta. Now tangent is opposite over adjacent. So this is on the negative side. So I want to make sure I put a negative there. This is on the negative side. I want to make sure I put a negative there. The reason that I put in the negatives is so that I get the signs of all of my other trig functions correct. I make sure that by putting those in, I'll automatically get the sine, cosine, cosecant, secant, and cotangent. I'll get correct whether those are positive or negative. Okay, my hypotenuse here, remember the hypotenuse is always going to be positive. And so if I figure that out, I'm doing -8 squared plus -3 squared is c squared. So that's going to give me 64 and 9. So that's going to give me 73. It's equal to c squared. So c is going to be the square root of 73. Okay, so when I'm finding my trig functions, I need sine and cosine. So sine is going to be opposite over hypotenuse, so that's going to be -8 over root 73. So that's going to be -8 root 73 over 73 when I simplify. Cosine is going to be -3 over root 73. Or -3 root 73 over 73. We were given tangent, so we need cosecant. Cosecant flips sine, so that's going to be -root 73 over 8. Secant flips cosine, so that's going to be -root 73 over 3. And cotangent is going to flip tangent, so that's going to be 3/8. So again, by putting these the proper signs in my diagram, that keeps me from having to worry about whether the trig function is positive or negative in the end, because I'm already dealing with that because I put the signs into my diagram. Okay, and the last example here is, let's see, cosine is negative, cotangent is negative. So if I go back up to my picture, cotangent is going to be negative in 2 and 4, because that's wherever tangent is negative. Cosine is going to be negative in 2 and 3, so I'm going to be in quadrant 2 here. So in quadrant 2, so cosine is, here's theta, cosine is negative 5 over 13. Hopefully you know your Pythagorean triples. That makes that 12. That's positive because it's on the positive side of the y-axis. The 5 is negative because you're on the negative side of the x-axis. Okay, so here we go. Sine of theta is going to be 12 over 13. We were given cosine, so I need tangent of theta. Tangent is going to be negative 12 fifths. Cosecant of theta is going to be 13 twelfths. Secant is going to flip cosine, so that's going to be negative 13 fifths. And cotangent is going to flip tangent, so that's going to be negative 5 twelfths. Okay, so that's what you're doing for that part of the assignment. The last part of the assignment is determining which line segment is representing the given function. Here's what you have to remember for these types of problems. We are dealing with ratios here. All of our ratios, so for example, remember that sine of theta is opposite over hypotenuse. Okay, so I'm looking for the triangle whose hypotenuse is equal to 1. Right, because if I can find the hypotenuse that's equal to 1, then the sine of theta is just equal to the opposite side. That's not a 0, that's the O for opposite. Okay, so let me demonstrate what I mean. In this, I've got 3 triangles here. I have a smaller triangle, I have kind of a medium-sized triangle, and then I have this larger triangle. In this smaller triangle, the hypotenuse is PO, so that's 1. In my medium-sized triangle, one of the adjacent sides, OR, is 1, because this is a unit circle, right? So all of the radii are going to be 1. In my larger triangle, in my larger triangle here, this side here, OC, that's 1. Now, think about what's going on here. This CS and OR are parallel to each other, right? Because they have the same interior angles of 90 degrees. So they would both be parallel, which means if this angle down here is theta, this angle here is theta. Okay, so I've got 3 different sized triangles with 3 different sides equal to 1. One of them has the adjacent side to theta equal to 1. One of them has a hypotenuse equal to 1, and one of them has the side opposite theta equal to 1. So we're just trying to figure out, based on the trig function, which one has the denominator equal to 1. So for sine, remember sine, like we were saying over there, sine is opposite over hypotenuse. Okay, so I'm looking for the triangle that has a hypotenuse of 1, and that's going to be this smaller triangle. So I'm dealing with triangle OPQ here. Okay, OPQ, so here's my theta, the side opposite theta, because I'm doing sine, the side opposite theta is PQ. The hypotenuse is OP. In this case, the hypotenuse is 1. And so I can say it's PQ over 1, or just PQ. Okay, I can do the same for cosine. So cosine, again, is adjacent over hypotenuse. So I'm going to use that same triangle. And that triangle, the adjacent side is OQ. So it'll be OQ over the hypotenuse of 1, or that would be OQ. Okay, tangent, remember tangent is opposite over adjacent, so I'm looking for the triangle that has the adjacent side to theta as 1. That's going to be this blue triangle. So the adjacent side to theta is TR. So that's, or excuse me, the opposite side is TR. The adjacent side is 1, so that's going to be TR. And that's how you're going to do those problems. I think the other 3 should be able to figure out.